let's continue seeing how logs and exponents can be used to solve problems. Okay, a little more algebra for us. Okay, so here we have -2 log base 4 of x is equal to log base 4 of 9. Okay, you might be tempted to just immediately take the logs out of both sides, like we did in the last problem. But first, you have to deal with this -2. Okay, this -2, remember, can become the power of the argument. No, you don't want to divide to the other side because then you'll just have a -2 in the denominator. It would not just divide this argument, okay? Because it is out front. So it is the power of the x. So change this to log base 4 of x to the -2nd power, okay? And then that is equal to log base 4 of 9. And now that we just simply have log base 4 of something equals log base 4 of something, then we know those somethings must be equal. So x to the -2nd power is equal to 9. Okay. So now you might be wondering, well, then how do I solve for x? That's a little complicated, right? But not really, because if we have x to the -2nd power and we don't want this to be x to the -2nd power, then we want to multiply by, we could really multiply by -1/2 power. Right? Because with power of a power, you multiply. And so we would need to do it to both sides. So this would also be to the -1/2 power. Okay. And that would be just x on this side then. Okay. Now we still have to figure out what is 9 to the -1/2 power. Okay, so, but we do know those exponent rules, right? So if you want to deal with the negative first, you could. So this would be 1/9 to the 1/2 power, right? Because that's what a negative does. It flips the fraction. And then the 1/2 power, remember, is the root, and that would be the square root. So this is 1 over the square root of 9, which would be 1 over 3. Right, the square root of 9 is 3. Okay, let's do another. So now we have log base 6 of x plus 4 plus log base 6 of x plus 3 is equal to 1. Okay, I hope you're thinking, well, we did just learn all those properties of logs, so we're probably going to have to use them, right? So we're going to want to combine this into one log. Okay, so that's log base 6. And then remember, this is actually the the product property. Okay, so x plus 4 times x plus 3, still equal to 1 on the other side. So hopefully you see that product property being used. We had 2 logs. To combine it into one log, we would then multiply. This is the m times n property. Okay, so now we could multiply this out, right? So we're getting x squared. I'm just foiling, right? The outer term is 3x, the inner term is 4x, so that's plus 7x. 4 times 3 is 12, and that's still equal to 1. Okay, now the real reason that we're doing this problem, though, is because we cannot just then cross out the log on this side, right? Do you see how this problem is different than the last problem we did, right? When we were able to unlog both sides, that's because we had a log on both sides. If we do not have a log on both sides, then I think the easiest way to do this is to turn it into exponential form. So remember that when you have a log and you can't solve for the x, you need to change to exponential form. And then you'll be able to solve for the x. So exponential form, the base is 6. Remember, switch the location of this and the 1. So it would be 6 to the first is equal to x squared plus 7x plus 12. Okay? Notice there is no more log. There's really not exponents. I mean, that's x squared, I guess, right? But that's a quadratic now. 6 to the first is the number 6. So this is 6 is equal to x squared plus 7x plus 12. So, this is no longer a problem from exponents and logs. This is a quadratic problem, and we're going to need to factor or use the quadratic formula. I would prefer, I think, to factor first. So either way you do it, remember that you need to have the quadratic equal to 0. You don't want it equal to 6. It has to be equal to 0. So that's x squared plus 7x plus 6. 12 minus 6 being the 6. Okay, let's see if that factors. Most of the time in these log things, it will factor because they want you to get some good numbers here. So I'm thinking it's 6 times 1 being 6 and then adding both of them. Wonderful, right? X plus 1 times x plus 6 is equal to this if you FOIL it. All right, so we got the two answers. X is equal to -1 and -6. Agreed? Okay. So now what we have to do in log problems before we finish the problem is check if the answer actually works in the problem. Because you cannot have a negative number in your argument, okay? So you can have x be a negative number. So let's look. If x is equal to -1, plug in -1 for x in the original problem. That's -1 plus 4. Okay, that's +3, so that's cool. And then if you plug in -1 here, that's -1 plus 3, so that's 2. So that's cool too. So this answer will work, okay, just fine. -6 though, if you plug in -6 plus 4, you get -2. Okay, think about the log. It starts at 0 and the x's go up. The domain of logs are usually 0 to infinity. This one has a shift, so this one is like -4 to infinity. This one is -3 to infinity. You can't use -6. This is called an extraneous. Oh, I'm writing behind myself. I'm sorry. All right, so let me just fixie that a little bit. Sorry about that. So we obviously know the second answer is -6, right? But it does not work in the answer or the argument of the problem. So this is called an extraneous solution. Okay. Extraneous solution. So you always do have to check for that. I've been a little bit sloppy and not saying that I checked, like for number 3, right? But this is 1/3, +1/3. When you plug this in for x, it totally works. It just has to be a positive number for the argument, okay? So I did check it, I just didn't say that I had.